Hi, I'm Ethan, and I'll be giving the demo presentation on behalf of Team 3, which includes myself, Sophia, and Bofu. Today, we'll be covering Textile's Filecoin Broker API and discussing the need for a decentralized archive. The topics in this presentation will be covered in the following order. First, we'll cover the story, then we'll look at the technology, then we'll go into the customer flow, and then we'll do a brief live demo before we end with a recap. So here's the story. March 2019, Hong Kong protest. January 16, 2021, US Capitol insurrection. June 21st, 2021, Apple daily news shutdown. These events are just a few out of many where centralized governments and organizations took matters into their own hands to limit access to data or information. Whether in the name of combating misinformation or controlling the narrative, the legality of these actions are suspect, and it makes us question, how free and secure is our data really? How free and secure our data is an extremely important question to consider. The reality is we are extremely dependent on our mobile phones and internet applications, and the backbone of all these both platforms is data. Our modern society runs on data, so understanding how the data is stored is important. Currently, the majority of our data is stored in server farms. Most data storage solutions are centralized. What this means is a single node is responsible for satisfying all server requests. If I want an image of a dog, I will need to send a location-based request to a server holding the image. If the server is accessible, then it will fill my request and send the data over to me. Centralized storage solutions have the following issues. They represent single failure points. If the server goes down, then the data access goes with it. Since server locations are known and owned by big corporations, it is very easy to block access to these servers, opening the door for censorship. Other disadvantages include lack of efficiency, privacy, and data misuse. As the world becomes more digitalized, the shortfalls of centralized solutions, storage solutions, become more apparent. The urgency of this matter is at an all-time high now, especially when we consider the importance of archiving. Archiving is the act of collecting historical documents or records. The act of archiving has been something that humanity has been doing for centuries. In the early days, archiving meant preserving manuscripts and recording the happenings of an era. The act was important because it served as a record of what to do and what not to do. Now much of the world's accounts are collected digitally. This collection of digital accounts makes up our modern history now and moving forward. There are times in history when these accounts are physically burned at the hands of changing regimes, attempting to silence narratives and control populations. The act has long-lasting effects as history literally turns to ash and fades away. Nowadays, these accounts are digital, and instead of literal burnings, you have server access shutdowns and information manipulation. Nowadays, we hear about authenticity of information. What isn't discussed because we take it for granted is information availability. When it comes to information, availability is just as important as authenticity. So how can we create an accessible digital archive? That brings us to the tech part of the demo and our discussion of the solution to the data storage crisis, decentralized storage. In contrast to centralized storage, decentralized storage is a peer-to-peer multi-node network. Decentralized storage operates differently than centralized storage solutions. First, the storage isn't owned or controlled by a large entity. You and I can be a storage provider for the network. Second, when a node gets shut down, it doesn't mean the data access is lost. This means censorship cannot happen easily because if a node gets down, it can pick it up in its stead. Content-based storage and retrieval means the data is more efficient, access is more efficient, secure, and verifiable. Filecoin is a decentralized storage protocol that launched late last year and represents the decentralized storage future. Despite its early growth, Filecoin is still young, and its archiving solutions, specifically offline deals, has a lot to be desired. Ordinarily, Filecoin storage deals operate in a linear fashion. Clients with data interact with Lotus protocol to create and submit to miners who accept and satisfy storage requests. Offline deals do not operate in this fashion because of the sheer size of some data sets. It is both inefficient and costly to transfer the data directly over the Filecoin protocol. Additional general issues with Filecoin include finding reliable miners, the need for technical expertise, confusing and inefficient offline deal process, and the need to have a fully synced Lotus daemon running. This is where Textile's broker API comes into play. Textile's tool hopes to simplify the offline deal process by removing the need to have a running Lotus daemon and handling the deal creation and miner selection process. Users will need to only be concerned with the preparation of the data itself. So let's take a closer look at how the Textile broker API works. So first, starts with the user. So the user has data and they must prepare it by generating CIDs, piece size, PCID, generating a car file, and creating a car file access point. Once these parameters are established, they can use the broker. They can use the API to send a request. When the request is sent, it gets sent to the auctioneer who creates an auction. The auction is then published onto an auction feed where miners bid on the deal via a bid bot. Winning miners will be granted permission to the deal. Once that's complete, it goes to the dealer, where the dealer will send the offline deal to the winning miner. The winning miner will then complete the deal process by importing the car file and then storing it on chain. Once the offline deal has been stored on chain, the deal information will be callable by the user via API. So let's see how this looks like from a customer flow perspective. Though Textile's broker API addresses some of the issues of Filecoin, data preparation is quite a complicated process in itself. This is where numbers can come in. Archivers or customers can come ready with raw data and provide it to numbers. Numbers will perform data preparation, which may include partitioning, batching, card generation, and execute the API call. When the storage confirmation is made, then numbers can go ahead and report the deal detail, the archive details to customers. Okay, so now we enter the live demo part of this presentation. So since Textile API was provided us, the time in the development was spent mostly in creating scripts to help improve or automate the deal making process. So let me share my terminal. So as mentioned, Filecoin is very young, so a lot of the tools or public APIs aren't, they're not mature. So some of the functionalities are missing. So like I created a few things. So like the first is the script here, which generates the parameters from a car file. So let's say that a customer has already done the heavy lifting and then generated the car file, and you just wanted and it gets sent over to you. You can run the script to generate the parameters so you can quickly send the deal quickly. So if I run the script, just wait for a second. So this is the car file. It's called Mayday because of you.car, and you run the script, and then you can see that it generates all the parameters for the deal for the API request. So S3 URL, payload CID, piece size, and this PCID is missing because currently there is no public API available that will help to calculate or generate this little information field. So another script that was written is, say that you have like a CSV file that has all the data. So let's say you have a spreadsheet that contains all the deals. So then let's say you have like a really long CSV file with a bunch of them, and you want to send all the storage deals in one go. So you can just go ahead and run this script right here from CSV, and then here, whoops. We don't have there we go. So then here, and then it'll generate the auction, the call, and then you'll use subprocess to run this shell script and then send it up. All right, so that's the live demo. And let me, almost done. As I mentioned, the last part is the recap. So I'm not sure if you guys were paying attention, but yeah, the recap. So recap goes like this. Yeah, so we live in an age where archives exist in digital forms. It's stored on centralized storage, then the accessibility is also at risk. So decentralized storage offers itself as a solution to create accessible digital archives to reference from and learn from. Filecoin as a storage provider, and Textile as a tool to bridge the technical gaps and shortfalls of the protocol and its infancy. And these are our values that we hope to achieve, I think. And yeah, that'll be all. Thank you.